Hello everyone. So the help session kind of had some technical difficulties, so I'm doing this walkthrough instead of posting the help session online. So this first walkthrough will just go over DQN, and in particular we'll be focusing on learn DQN. These first two functions are incredibly easy, so I'm not going to spend a ton of time on them. Get action DQN is it's just an if-else statement. If a random number is less than epsilon, then choose a random action. Otherwise, choose the best known action by taking the argmax of the network, or the argmax of the output of the network. And then also, of course, returning a decayed version of epsilon. So you take epsilon decayed, you multiply them together, then, epsilon shrinks every single time. So that's get action DQN. And the purpose of that is because, we're trying to balance exploitation and exploration. So when we take the optimal choice, the argmax of the output, what we're doing is we're exploiting, to the best of our knowledge, this is the best choice. And then on the other hand, when you are when you're choosing a random action, you're exploring, right? And so over time, because of the epsilon decay, will shift from being mainly exploratory to being mainly exploitative. So that's get action DQN. Prepare batch is also very simple. You're going to be given a list of tuples that come like this, and you're going to break each of its elements up this way. Oops, sorry. Going to break the elements up this way and turn it into a series of tensors that look like this instead. Right? So point is, if this is the state, it used to be that there was a state, an action, other stuff, and the reward, and all of these things came in one tuple. But instead we're going to break them apart and have all of the states here be collected and put into a tensor here. Right? Now, of course, we're not going to do the entire list of tuples. We're going to randomly sample them. You can randomly sample them yourself if you want, but there is a very simple algorithm, function that you can call, and that is random dot sample. So just Google this function. It's a Python function. It's not a torch function, but it will make it very easy to randomly sample the tuples out of this list. Learn DQN has 4 different steps. All learning loops have 4 different steps. You zero the gradient. You calculate the loss. You call loss dot backward, and you call opt-in dot step. So really all we need to do is talk about calculate loss, and for this function there actually is one more step, which is that occasionally we need to update the target network. Okay, so those are the 5 steps. Okay, so this is the loss function, which is the majority of what you need to know. And the only important thing is you should look at this 1 over n times the sum of a difference squared. Okay, those three elements should immediately tip you off, or those four elements, sorry, should immediately tip you off. This loss is essentially a mean squared error. The 1 over n is a mean, the sum is a sum, the difference is the error, and squared. So mean squared error. Now, in the TA code, they actually do not calculate the mean squared error, they calculate the sum squared error. And I want to point out this is actually not all that different, because 1 over n is just a constant factor, so when it doesn't change the location of any of the minima or maxima. It does change what they are, but it does not change their location. So while it might change the speed at which you get to a minima, it will not change the direction at any point. It'll just change the magnitude. And you know, those are things that you can compensate for with a learning rate anyway. So sum squared error, mean squared error doesn't make that much of a difference. It does make a little difference though. Okay, but the important thing is that we're taking these two different things and we're comparing them and trying to get them to be the same. The first thing is what we predict the Q value is based on the current state and the action that we chose. And we're going to take the difference of that with the reward that we got for this state and action plus a discount factor of what we think we will get in the future. So Q represents the network that we are currently learning on, and Q hat represents our stashed network. We stash Q into Q hat every so often, and Q hat is essentially, we are pretty confident that these rewards and these returns are consistent, and so we can rely on them to predict future rewards. Whereas Q, we're going to use that to update. Now this is a really important point. We are trying to get Q to predict your return. And remember, the return on your investment is equal to your current reward plus gamma times your reward at the next time step, t plus 1, plus gamma squared at the next time step, so on and so forth, right? So it's this thing. And so we know what the return is, what the reward is, and so the Q network is essentially trying to predict the rest of this. And that's what it's trying to learn how to predict. So what we would like to be able to say is, oh, well, the Q network equals R plus the Q network, but at different time steps. So the Q network at t equals 1 equals the reward we got plus the Q network at time 2. Right? We would like to be able to say that, but if we're defining our loss function in terms of itself, well, now you're going to get some back propagation problems. So instead of having this be Q and Q, we're going to have this be Q and Q hat. So it is partially to take care of the back propagation problems. The other thing that it's useful for is if you wait to update Q hat for a certain number of time steps, of learning steps, then you're fairly confident that Q is the real rewards that you're getting. You're not getting spurious rewards because it's seen multiple iterations, and so we're fairly confident that this is accurate, more statistically significant. So that is why there's a difference between Q and Q hat. They're the same network in structure, and Q hat is literally assigned the value of Q, right? but they have different underlying parameters. Q is updated regularly, whereas Q hat is only updated every so often. Okay, so that's the difference between Q and Q hat. But I'm going to call this first thing, let's just call that loss A, and the second thing is loss B. And the overall loss is going to be the mean squared error of the two of them. So let's start with QSA. QSA is the predicted return for a given action in a state, right? So what that means is that we put one state through the network, and that network will give us out a probability or a score for each action. And that score represents what we believe the return for that action is. And so we want to get the value for the action that we actually took and discard the rest of them. And we're going to do that using torch.gather. So you'll need 3 parameters for torch.gather. And they will be, okay, so in torch.gather, you'll have to look up the documentations to get this specific, but here's just some pseudocode. The first thing you need is the values you're trying to get out, the dimension along which you want to get them out. In our case, it will be the first dimension, which is the last dimension, and the index of tensor that you're using to index into values. So this will get you, if you view this in the right way, I don't know, it's probably like unsqueeze once or something like that. If you view this in the right way, then this will be all of the expected returns for the actions that we took in the given state. Now we're contrasting that with the actual return that we got, the actual reward that we got, plus the estimated return for steps even further down, right? So this part I'm going to call loss B. Now the important thing right here, D represents whether we are done or not. D is 0 if we are not done, and 1 if we are done. So if it's 0, we're multiplying by 1, it's literally doing nothing. If we are done, then it's 1, 1 minus 1 is 0, and we're just removing this part of loss B and making it so that it's nothing but the reward. Now this makes perfect sense, because do you believe you're going to get a future reward when the game is done? No, the game is done. You can't play the game anymore. So that's the point of the 1 minus D. So it's loss B is going to be equal to, let's write this down. Loss B is going to be equal to the reward plus gamma times the max of Q hat. So torch.max of Q hat. Q hat you will get from the target network. Q comes from the Q network, but Q hat, Q hat comes from the target network. Okay, so you get the torch.max of Q hat multiplied by 1 minus D as an integer, so that you don't get any, 0.000000001 sort of thing. You don't want any of that. You want a true 0. Okay, and so there's your loss B. And then finally, you just your overall loss is equal to your is equal to the torch dot sum of loss A minus loss B squared. And again, you know, if you want to do the mean squared error, that's probably like more technically accurate, but they have the exact same. They have different minima in the exact same spots. So, you know, the gradient descent will be always in the same direction, even if it has a different magnitude. Okay, so that's how, and then of course after, you always do loss dot backward and optim dot step, yada yada yada, all that stuff. I skipped all that stuff from above anyway. So the last thing you need to do is remember that Q network is being updated directly, but the target network is not being updated. We cache it every now and again, so that we only get versions of the model that we're pretty confident are like legitimate. We're never going to have a spurious episode that takes us way off course, and then that's going to end up being our Q network. That's not going to be the case because we're only going to cache it, you know, every 50 steps or so. If it's time to cache, let me try to spell that again. If it's time to cache, then we're going to use one network dot load state dictionary. You'll have to look up this function to see how it works, and the dictionary that we're going to be loading will come from the other networks state dictionary. These are not actually the functions. I'm intentionally just telling you what they are, but I want you to go look up the functions yourself, so you can see exactly how they work and figure this out. So there's your pseudocode for Learn DQN. Thank you very much for watching this YouTube video, and have a good luck on the lab.